After decades in the making, the James Webb Telescope, JWST, finally launched on 25 December 2021. NASA has worked for nearly 3 decades to craft this telescope and get it to the launch pad. And guys, in today's video, we will be telling you everything we know so far about James Webb Telescope. Without further ado, let's begin. The future is now. Sporting the biggest mirror of any spacebound telescope ever launched, James Webb Telescope is tasked with collecting infrared light from some of the most distant stars and galaxies in the universe. With this capability, the telescope will be able to peer far back in time, imaging some of the earliest objects to have formed just after the Big Bang. On top of that, it will unravel the mysteries of supermassive black holes, distant alien worlds, stellar explosions, dark matter, and more. Since its Christmas morning launch, the James Webb Space Telescope has made all the right moves. Now it has passed through the final stretch of its complex deployment phase. In these terminal steps, 2 panels on each side of the telescope's array of 18 gold-plated hexagonal mirrors, folded back during launch, were snapped into place to complete Webb's honeycomb-like reflector. The 21-foot wide mirror sends light from the cosmos into a secondary mirror, which then bounces the light into the telescope's main infrared sensor. Unfolding the mirrors is a crucial milestone along the way to using the telescope for scientific studies of the Big Bang, exoplanets, black holes, and our solar system. Now that it has been completed, NASA considers the telescope fully deployed. When will the Webb telescope finish unfolding, and how can I watch it? The telescope's unfolding phase wrapped up Saturday morning after the mirror segment's right side panel of its 3 remaining mirrors was secured into place. The left side completed its deployment on Friday, a process that took 5.5 hours. A NASA live video stream showed mission managers monitoring the deployment from the mission control room of the Space Telescope Science Institute in Baltimore, the telescope's center operations hub. Around 5:53 a.m. Eastern Time, the mission's manager sent the first command to begin unfolding the mirrors. Shortly after 10:30, the panel slowly swung open so that the 3 hexagonal mirrors tessellated snugly with the other 15. Staff applauded before moving on to the next step of latching the mirrors into place. That process concluded at 1:17 p.m. How does it feel to make history, everybody? You just did it! Thomas Zurbuchen, NASA's science chief, said in remarks to the missions at the Space Science Telescope Institute in Baltimore. Why aren't there cameras on the telescope? Rockets and some spacecrafts carry built-in cameras so engineers on Earth can monitor their behavior in space. So one would expect engineers to pack cameras aboard the James Webb Space Telescope, the most expensive and technically complex observatory ever launched into space, with 344 single points of failure. Think again. There are no monitoring cameras on the telescope. Instead, engineers depend on switches, sensors, and motors to track its health during deployment. NASA ditched the idea of including surveillance cameras on Webb because of technical complexities and risk. The telescope's novel size and shape, with one side of its sunshield deflecting enormous amounts of heat and sunlight and the other instrument-heavy side basking in frigid darkness, would require multiple custom-built cameras. Wires and mounts for those cameras would add weight and risk to an already heavy telescope, the agency explained in a blog post. It's not as straightforward as adding a doorbell cam or even a rocket cam, said Paul Geithner, NASA's deputy project manager for the technical side of the Webb program. Earlier in the live video program, Dr. Zurbuchen described himself as feeling emotional when the telescope's mirrors finally clicked into place. "What an amazing milestone," he said. "We see the beautiful pattern out there in the sky, now almost complete." But it wasn't possible to see what was happening on the telescope itself. What else has happened to the telescope so far? Since Webb's launch, engineers have completed over a dozen main steps in the deployment phase to bring the telescope to its final form, involving hundreds of moving parts such as switches, motors, pulleys, and cables. The process began less than 30 minutes after launch last month, when Webb's solar array deployed, the only step caught on video as the telescope parted ways in space with its rocket, which had an outbound camera. If you are enjoying the video, then make sure to hit that like button and subscribe to the channel for more amazing videos just like this. The telescope has passed a number of milestones since, doing well to diffuse astronomers' anxiety and quell fears that a structure as intricate as Webb was bound to run into snags along its million-mile trek to the place in space where it will stay. The telescope powered on, deployed antennas, mechanically unfolded various limbs, and, in the most technically complex milestone, delicately stretched taut 5 layers of tennis court-sized plastic sheets designed to shield the telescope's ultra-sensitive camera sensors from the sun's heat. Why is the telescope so important to scientists? The Webb telescope was designed to probe a crucial stretch of early cosmic history, known to astronomers as the Dark Ages. Cosmologists surmise that the first stars appeared when the universe was only about 100 million years old. Today it is 13.8 billion years old. The farthest and earliest galaxy seen by astronomers using the Hubble Space Telescope dates to when the universe was older, 400 million years after the Big Bang. What happened during those intervening 300 million years when the universe took luminous flight? How the Big Bang turned into a sky full of constellations and life is a mystery. The telescope will also help astronomers better study supermassive black holes at the center of galaxies and planets orbiting other stars in our galaxy. To achieve these scientific observations, the Webb telescope relies on a primary mirror 6.5 meters in diameter compared to the mirror on the Hubble, which is 2.4 meters. That gives it about 7 times as much light-gathering capabilities and thus the ability to see farther into the past. Another crucial distance is that it is equipped with cameras and other instruments sensitive to infrared, or heat, radiation. The expansion of the universe causes the light that would normally be visible wavelengths to shift into longer infrared wavelengths, normally invisible to human eyes. Engineers had to invent 10 new technologies along the way to make the telescope more sensitive than the Hubble. Over-optimistic schedule projections, occasional development accidents, and disorganized cost reporting dragged the timeline out to 2021 and ballooned the overall cost to $10 billion. Make your phone into a personal planetarium. To understand the observation powers of the James Webb Space Telescope and how it will assist astronomers in their research, try these 2 augmented reality experiences in your own space with a smartphone logged into Instagram. The first will show you where in space and time the Webb will look with a 3D map of the observable universe. It plots some of the spacecraft's early targets, including potentially Earth-like exoplanets and the earliest known galaxies. The second augmented reality experience shows how the Webb will get a visual boost from the power of gravitational lensing. Place a virtual black hole in your space and watch how it behaves like a magnifying glass on your surroundings. This same technique will help astronomers study the early universe. So guys, let me know down in the comments section below. What are your thoughts about it? For more interesting content, give this video a thumbs up and don't forget to subscribe for more awesome content. Have a nice day, and I will see you in the next video.